All right. So, reminder, next week, if you are able, uh, most of you, I assume, are able to come to class in person. If you are an online only person and that is not realistic, contact me and we'll come up with an alternative. But next week in class, there's going to be a student-led workshop hackathon type thing in here that the next homework assignment, the one that's due Sunday, is going to kind of prepare you for. I did update that assignment. I don't know if did I say that here in class or online or whatever. I think the homework from the book sucks. So, so I'm going to start updating it now that we're caught up to things. So, all right. So today we're going to be talking about very complex mathematics. How many of you have heard of fractions? All right, so now we get to learn how much you've forgotten about fractions. um, we're starting to trend towards learning about objects. So we're going to continue. Well, we're going to start using lists here in class. Your homework assignment has you working with lists. Then we're going to look at dictionaries. Then we're going to look at objects, all of them dealing with fractions as our starting point for our example. All right, so for example, we have like the fraction 1/2 or the fraction 1/4, right? Those types of things. All right, so in this guy, what is the 1 and what is the 2 called with fractions? This is the numerator over the denominator. So that's what we call those dudes, right? All right. So now what if I wanted to add some fractions together? 1/2 plus 1/4. How do we do that? Good. All right, figure out a common denominator first. How do we figure out a common denominator? If I have 1/2 and 1/4, what is a common denominator? All right, so 4 is a common denominator. How did you get to 4? We need to be able to describe this to a computer. Huh? Okay. How would you explain to a computer how we take 1/2 and 1/4 and ultimately end up with a common denominator? Okay. So how would you do that? How would you determine what the greatest common divisor is of two numbers? Use the percent thing. Let's keep it simpler. What is a common denominator of these two fractions?
You want just a common denominator, the lowest.
A.
Just multiply them together.
8, right? We have 8. And that one's pretty easy to explain. Multiply the 2 by 4. We get 8. Okay. Now, we do have a lowest common divisor of both of these guys that we are going to be working with. But for right now, we know we can get accurate math by just multiplying the two by each other. So 1/2 we multiply by 4 to get ourselves 4/8 plus 2/8, which is going to be equal to, oh, perfect, nice. I can't even get a fraction, so that gives us 6/8, right? And then we can reduce from there if we want. But let's just start off with things that we can explain. All right, so remember we're working on the skill of taking real life stuff and turning it into a computer program, and we need to practice explaining to this guy. We have our ideal reduced fraction, but then we have a, hey, we need this to work. All right, so now based on what you know right now, if I wanted you to create a program to add two fractions together, how would you represent fractions in your code? Couple of variables? Could use two variables? Okay. So, for example, by here, and I say n1, well, let's call it num1 is equal to 1 for our 1/2. Oh my gosh, are you kidding me? Just don't help me. Num2 is 1. We'll keep these guys on top of each other. denom 1 is equal to 2. 2 is equal to 4. All right, so we've just picked 4 variables to represent our numerator and denominator of our things. Seems a little bit less than ideal, but it's what we know how to do right now, right? Okay, so now we want to get our common denominator. So what would I do here to give me my common denominator? Yep, so denominator 1 times denominator 2. In this case, that's going to give us the 8, right? All right, but now we need our updated numerator 1 and our updated numerator 2 after we get our common denominator. So we can say new num 1. So new num 1 is equal to what? How do we get the updated version of num 1? Go back to our picture here. So how did a 1/2 become a 4/8? All right, so we do cross multiplication. Remember that guy? So we have the 2 fractions next to each other. We multiply the numerator of 1 times the denominator of the other. We multiply the numerator of the other one times the denominator of the first one. Those are our 2 new numerators. All right, so new num 1 will be num 1 times denom 2. New num 2 is equal to num 2 times denom 1. So sum, let's call it sum num, is equal to new num 1 plus new num 2. And then ultimately our final answer is sum num over com denom, right? All right, so if we print those 2 things out, we can say print out sum num, print out common denom. Go ahead and run this guy. And there's our 6/8. All right, so all the math worked out there, right? But that was pretty tedious, just throwing a whole bunch of stuff into a bunch of variables. At least we had the limit of we were only adding together exactly 2 fractions, wasn't the end of the world, but lots of stuff there. Can you give me an alternative way that we could represent fractions? Go ahead. Could represent them as a string, okay? So let's go down that path. So instead of representing 1/2 in 2 variables like this, we could decide that, let's see, do I want to, here, I'm going to save this. Variables. Variable representation. It's going to be that guy. Now we're going to make some changes to it. All right, so you want to say like F1 is equal to 1/2? Okay, fair enough. So now we've decided to represent our fractions differently. We were representing them as strings. Okay, I still want to add these together. What do I do next? Oh, we got to find some stuff, right? Before we had these nice clean variables where everything was already self-separated, but it didn't look very clean to us. It didn't look like a fraction. Now we can glance at this and these look like fractions, but now we need to be able to extract our pieces from it. So let's go ahead. Gonna get there. Yep. But I want to extract my 1 and my 2 from this string. So let's just forget about adding fractions for a second. I want to have code that takes a string that looks like this and gives me the 1 and gives me the 2. So I want to get the numerator from something that looks like this, and I want to get the denominator from something that looks like this. So let's just write a little function here. So define get numerator, and this guy will take in a fraction string as a parameter. So our fraction strings, we're going to say looks like this. And this guy should return, in this example, a 1, the number 1, the numerator out of this thing. So how am I going to accomplish that, using what you've learned in class so far? Go ahead. Okay, so you want to walk through this string from beginning until we finally hit a slash. All right, and I'll go ahead and throw a caveat. You can assume there's no spaces in here for our example here. We don't need to make it any more complex. All right, so you want to create a loop that goes through every character in this string, right? And starts and is looking for the slash. So let's just get to that point. Let's just look for a slash. So I'm going to stick with the loops we've been doing, but we're going to transition into a for loops using in here during today's class. But let's keep one new thing at a time. So we'll start off at positive 0 because that's the first legal place in my string, right? And we're going to say while fraction string at position pause is not equal to a slash. So if it's not equal to a slash, we start at bucket 0. We see a 1. Is a 1 equal to a slash? It's not. So what do I want to do with it? Okay. Okay, but I need to do something with it. I mean, I can just say pause is equal to pause plus 1 here. And then afterwards, I can do something like print slash found at position pause, something like that. We'll call get numerator on F1. So I have my fraction that looks like our fraction string stored inside of F1. I'm going to go ahead and pass that guy to get numerator. It's going to start off pause at 0. Keep asking the question, is the current character we're looking at it, position pause, not equal to a slash? If it isn't, just add pause equals pause plus 1. As soon as I finally find my slash, we'll fall out of this while loop, and I'm just going to print out where we found that slash. We should have found it at bucket 1, right? Oop. Oh, pause. So we need this guy to be a string for this example. All right, so there's my position 1. Go ahead. Okay, so you want to create a string variable and start it off. Well, what I heard you say is you want to build up our answer. Okay, so if I want to build up a string, what should my string variable start off as? Empty string, that guy, right? All right, so I'm going to build my answer. In this case, answer, we're just going to name our variable answer, but it doesn't matter what you call it. Just that kind of makes sense. The answer we're looking for is the numerator. We've decided we want to build up our numerator by using concatenation. As we're walking through this string, one character at a time, as soon as until I see a slash, I want to collect characters, right? All right, so we'll go ahead and give ourselves another variable here, answer. It's the empty string. All right, if I'm in this while loop, if I'm in the body of this while loop, I know that the current character we're looking at, the character at position pause, is not a slash, right? Okay, so what do I want to do with it? I want to take my current answer. I want to set it equal to whatever it already is, concatenated with fraction string at position pause. So the first time through, we would be looking at the character 1. Is it true that a 1 is not a slash? That is true. So we'll go ahead and tack on to answer whatever it used to be, which is the empty string, concatenated with the character at position pause. So this is going to give me the char. Good.
Another way you can do it is just mark down the position of the slash and the string, and then use slicing to slice both sides into
So there's probably about 8 reasonable ways of accomplishing this, and we're going to be walking through it in stages from, let's call it, our first version there with variables was a pretty ghetto approach to it, but worked, right? And then, and I would say this is kind of my problem with Python, is Python has too many built-in things. That's why I keep saying using only what we've introduced in class, because I'm trying to introduce stuff in class that is common to any programming language. One thing that is kind of unique about Python, and some other languages have similar type things, but I feel like Python's the worst at this or the best at this, depending on what your worldview is. But Python has a lot of built-in functions that just kind of do things that might be handy in very specific situations, but it takes away from your problem-solving learning, so that when you get into a language you need to do something that isn't built in, you're going to have to write it yourself. So we want to write as much stuff ourselves as we can, but without just purposely making it more difficult. Sometimes we're going to use built-in functions like we talked about that index of function, or I think it's just called index in here. Every programming language has one of those. Something that lets you search for something in the string. Could be handy in this case, knowing where the slash is. But in this case, we're taking a very direct approach to it. We're going to say, okay, I want to build up my numerator. I'm going to start at the beginning of the string. I'm just going to start walking one bucket at a time, collecting digits until I finally hit a slash. Okay, so now I'm standing on the slash. I've collected however many digits I've had up to this point. I have them stored inside of answer. I've run into the slash. What do? Return my answer. This guy has the result, right? So when we exit this while loop, we are exiting this while loop as soon as fraction string at position pause is equal to a slash. That's when this while loop ends naturally. And we do not tack on that slash inside here. While loops are pre-check loops, which means we process that Boolean expression prior to the body of the loop. All right, so when we fall out of the loop right here, we can return our answer. Now, what kind of value is answer right now? It's a string. Okay. Now, if we're going to be doing mathy stuff with it, we're probably going to want to have it in a number, but we can deal with that at a later stage, right? We can decide if we want this guy to return it as a number or we want this guy to return it as a string. But let's just make sure what he's returning is the right thing to start off with. Then we'll make sure it's the right kind of thing. All right. So now we can go ahead and call get numerator. Doing all this, collecting up our answer, returning answer. So what's the output of this program going to be? Good. Eventually, I'll just stop asking once we start getting the instantaneous answer. So it's not going to be anything because we're not doing anything with the return value, right? This guy right here boils down to the string that's being returned by get numerator, but we're not doing anything with it. All right, so for right now, we'll just go ahead and print this out. And we're expecting, if this is working on 1/2, we're expecting this is going to give us a 1, right? All right, so there's our 1. If we doctor this guy up a little bit, so we do 123 over 2, now we expect it's going to give us 123 as a string. We're collecting all the numbers before the slash. So we'll run this. So there's our 123. All right. So we feel pretty decent that we're extracting the numerator now. And we know there's some built-in stuff. If I want this string in an int, I just do the int thing and it converts it to an int. Every programming language will have a facility in it for taking a string that holds a number and turning it into an actual number. But even if we didn't have that, we've written base to decimal and decimal to base, so we can take a string representation of a number that happens to be in base 10 and convert it to the numeric version of that in base 10. We know we can get 123 out of this by using our way overpowered tool that we built for doing that. We're not going to need to do that, but we could. You know, we can convert base 10 to base 10 and we will get the correct answers. All right, so we're getting the numerator. So now we want to write something like get denominator. And then for those of you who are looking for things you can practice outside of class. Now, next week, I'm going to be giving you like 30 functions kind of like this. I'll give you a scenario and say, here's what we're trying to do. The input looks like this. The output should look like this. Do it. Okay. And as an in-class exercise, you're going to be getting through as many of those as you can, kind of drilling these abilities. So try not to look at things like this as wastes of time because you are practicing logic. If you get good at this stuff, you'll be able to solve any problem. So fine, fractions are boring. So is most of the stuff that you're going to be dealing with once you dumb problems down to little tiny sub problems when all you're looking at is something that doesn't have that much meaning. It's just the next little puzzle piece you need for the rest of your problem. All right, so if we want get denominator, we're also going to take in a fraction string here. So it might look like 1/2 or whatever my, doesn't matter what I have in there. All right, so it's going to be in this format, what these guys look like. And now when I call get denominator, so if I were to print get denominator on F1, I'd want this to give me the 2, the denominator portion of this. All right. How do I accomplish that? We could take a little inspiration from our get numerator, right? Maybe building up a string makes some sense. Okay, go ahead.
Oh, I was gonna say you could reverse the way that your numerator function is. So instead of reading it from position 0, I would do it at the length of the fraction string -1.
Okay.
And then instead of incrementing forward for position, you increment back. And then lastly, just for like answer equals answer plus fraction, just like switch fraction string at position, pause, and answer. So
Build it backwards.
essentially, so
Yep.
it's not giving you the backwards denominator.
Right. So she wants to start here at the end of the string and start walking towards the beginning until we hit the slash, collecting the numbers as we hit them, but build our string in reverse. Or you could just reverse it at the end because we know we're collecting those numbers backwards. So if this was 1/24, for example, we would end up getting 4 then 2, a 42, when we really wanted 2, 4. All right. Certainly, this would work just fine. Reasonable enough thing. There is a function inside strings called reverse. So, but what if we just wrote our own reverse string? I think we've already even done that, right? So let's just say in our head, we're not necessarily sure that there is a reverse string built into the language. It's an easy enough thing. So let's just build reverse string. This guy will take a string as a parameter. We're going to create a new string, start it off as the empty string. We're going to start at the end of our string, walk towards the beginning of our string, building up our answer. So we'll say pause is equal to the length of a string -1. So if you were to describe to me the value that pause holds, what is the meaning of the value that pause holds here? Yeah, the last legal position in the string. All right. So now we'll say while pause is greater than or equal to 0, we want to do something. What are we going to do? We're going to say answer is equal to answer concatenated with a string at position pause. And then pause is equal to pause minus 1.
I think you have to switch answer and a string.
Remember, we're only reversing stringing right now. Yeah, we're solving a sub problem of your problem. Yep. All right. So give us a new string here. Start at the end of our string. Keep going as long as pause doesn't fall off the front of our string. Build up our answer as we go. And then as soon as we're done, we can return answer there. And if we want to test this, we can say print. Here, I'm actually just gonna. So we're gonna print reverse string on F1, which should give us a 2/123. Oh, I didn't indent something because I didn't finish writing that. And it's a capital S for a string. All right, so as a starting point, we have it in reverse. It's literally the reverse of it. So everything is now backwards. If I had something that looks like this, I have my answer. Let me actually do it like this so we can view this in a way that gives you the right hint. So if I reverse it, I get this guy currently is 123 over 23. So I'm getting it as 32 over 321. Now, well, let's just stop here. I want to come up with a solution for get denominator. That utilizes our reverse string and also utilizes our get numerator. Good. Okay, so I can reverse it first. So maybe call this guy temp and say reverse string, fraction string. So now temp will be that guy backwards. All right. Then you said you want to call get numerator. All right. So we can call get numerator on this guy. And in our example right here, it would get us a 32, not a 23. Right? All right. So we're going to say backwards num is equal to get numerator of temp. Temp is our reverse string. Pass that in to get numerator. It's going to extract what was the denominator, but as the numerator, but backwards. So that's going to give me the 32 here. All right, what do I do next? Reverse that. So answer is equal to reverse string backwards and then return answer. So there is our correct answer for the denominator. Here's our correct answer for the numerator. We built get denominator in terms of get numerator using our handy dandy reverse thing. It's not overly straightforward, but I threw a couple of toys in front of you and you said, okay, I can use these guys together to solve this problem. We MacGyvered a solution. Yeah, reversed it the first time so that my denominator became the first part of it, the part before the slash, extracted that, which was my numerator, but backwards. And then I reversed that to get my denominator forwards. Who cares if it's doing extra work, right? Now, this is probably not the way I would have done it. but it is a way to do it. It gave us a reasonable enough answer, right? So we could write this differently. So let's say get denominator, we'll call this guy 2. Give ourselves several different versions of this. So get denominator, and let's say in this particular case, we're not going to implement it in terms of get numerator. We want to write this guy a more direct way. Now, using the reverse thing kind of is in the spirit of how she described doing this answer, kind of building it backwards, starting at the end. So we can do that. We can say answer is equal to the empty string. We can say pause is equal to the length of fraction string minus 1. So pause is going to be a number, which is the index of the last legal place that lives in my string. That's where the -1 thing comes from. If there's 5 elements in a string, it's 0 to 4. Length minus 1 gives me the 4. All right. Now she wanted to walk our string from the end towards the beginning. Okay. So we're going to say while pause is greater than or equal to 0. Right. So we're walking it from the end towards the beginning. She wanted to build up her answer, but she wanted to do it slightly backwards. So we're actually concatenating it. We're building it in reverse by just using concatenation in the opposite way we did before. So we're going to say answer is equal to fraction string at bucket pause concatenated with answer. So instead of saying answer plus fraction string at pause, we're saying fraction string at pause concatenated with answer. So we're building it up in reverse. So it'll already be facing the right direction for us. First time through, if I look at my example here, we're going to get this 3, concatenate on the 3, so we have the string 3. The next time through, if we concatenate the normal way, we would get 3, 2 instead of 2, 3. But by concatenating them in reverse here, we build it up as 2, 3. All right. Now, if I just keep going with this, so I need to decrement pause. So pause is equal to pause minus 1. So we're walking from the end of the string towards the beginning of the string. Now, if I just do this directly right now, I do nothing else, and I say get denominator 2 on F1. So get denominator 2 on F1 is going to give me a what? Oh, did I not return anything? You're right. That's not the question I meant to ask, but it is the question I asked. So now we're returning answer. So if I pass in to get denominator 2, the fraction 123 over 23, what will this guy spit out right now? It's not the denominator yet. Everything. All right. It's not in reverse because we built it in reverse, right? We walked from the end, but we built it up in reverse. So we actually get everything we get everything in the forwards way because we built it in reverse. So because of the way we did our concatenation, if we had chosen to turn these guys around, yeah. So this was the magic. I would say that even though this is a common thing to do, sometimes students have trouble wrapping their mind around concatenating backwards, even though it works just fine. There's nothing super special about it, but if you're trying to visualize these problems, at this point, most of you will find it helpful to draw a lot of pictures for what you want to do. All right, but right now we're building the entire thing, whether it's in, backwards or whatever, we're not making a distinction between numerator and denominator right now. So let me go ahead and get this guy back to building it in reverse like we did before. All right. So if I want to make sure that oh, go ahead. Mhm. So we could say, you know what? Now, first of all, that makes this assumption that what we're passing into this fraction string plays by the rules of what we've said a fraction string is. That is a numerator followed by a slash followed by a denominator. Somebody technically could call our function passing at the number 17, and things are going to break real quick. We're not going to do a lot of error checking for this. We're working on the logic, so we'll just trust that they pass as a legal input. All right. So instead of saying pause greater than or equal to 0, you want to say keep going as long as fraction string at bucket pause is not equal to a slash. Because we know that we're going to run into a slash way before we get to the front of the string. So we don't need to worry about it going to a negative number. We're just going to say, I'm going to start at the end. I'm going to start walking towards the beginning, looking for slashes. As soon as I find a slash, what am I going to do? I'm going to fall out of my while loop. I'll return the answer. And now we have our 23, which was the denominator. Go ahead. Well, it depends on what you're error checking. If you're going to say, okay, I want to make sure they pass me a legal value, then you would probably want to cover your bases on what does it mean to be a legal value. That is, every single character other than the slash must be a digit. You know, they can't give me a question mark or something like that. That'll cause it to bail out. So you can kind of decide at what level of error checking is important. At this point in your programming careers, I wouldn't spend a ton of time error checking. More time practicing the logic. And if you pass a bad input to your function, shame on you. If I pass a bad input to your function when I'm testing it, shame on me. You know, you wrote the function to work on the kind of thing I told you to make it work on. If I didn't know how to use it right, you know, it's kind of like when you're putting stuff into a blender that shouldn't be in the blender. Or throwing, oh, my brother and I used to, I think I told you, with the VCRs, we used to put toast in there. Well, I think it was bread. We thought it would be toast, I hope. I know. Trying to figure out at what level of stupid my brother and I were. Probably wasn't good. All right. So now we have our denominator another way, starting at the end of the string, walking towards the beginning of the string, looking for when we run into a slash, collecting everything that's in our denominator, but building it in reverse. That way I don't have it backwards, and then ultimately have my answer. Okay, so now I have the ability to get a numerator and the ability of getting a denominator from something that looks like a fraction. And this is us choosing to represent our fractions as strings. Okay. So my fractions look like this. All right, so now I have my numerator, I have my denominator. Now I want to write a function. Add fractions. And this guy will take in a fraction string 1 and a fraction string 2. So it's going to take in two separate fraction strings because I'm adding two separate fractions together, right? All right. So how do I get, I can, if we want to just go back to what we did before, I want to fill up four variables with our numerators and denominators, right? So I can say num1 is equal to get numerator of fraction string 1. That will get me the numerator from that guy. Let's leave it like this for a second so we run into our issue. We'll say denom1 is equal to get denominator. Doesn't matter which of these two we pick. They both give us the right answer. We just go about it a little differently. So I'll pick my get denominator 2. We'll pass in fraction string 1. That'll give us our first denominator. Numerator 2 is get numerator. Fraction string 2. Denom 2 is get denominator of fraction string 2. All right, good. but it's hidden from us. Because right now, what I can do down here is I can say F3 is equal to add fractions F1 comma F2. So this is what main looks like. All programs begin and end with main. We know when we talked about our object-oriented versus our procedural telephone, the difference between the pile of wires versus, we visually see the pile of wires versus knowing that there's wires inside of there, but we don't like to see them. We know that there is going to be some complex-ish logic somewhere. Whether we peel it out into individual variables, we're going to be looking at lists here in a second, but doesn't necessarily matter as long as it's A, giving us the correct output, but B, hidden from the user enough that the user can just look at the program and say, oh, this makes sense. You have a fraction, you have another fraction, a function called add fractions, probably add some fractions. I'll pass my two fractions to that guy. He's going to give me the result, which I hope is those two fractions added together, and then I can print the result. All programs begin with main, begin and end with main, so main kind of is our quarterback, even though it's calling upon other places in our program. When all is said and done, your main method in your program should almost always be pretty short like this, relative to the size of the problem you're solving. All right, so we have our numerator, we have a denominator. Now we decided that we could have a common denom, and we decided that this would be denom 1 times denom 2. All right, so just going to stop right there, and we're going to go ahead and run this and see our first issue. All right, so we're getting a problem right here. It's saying we can't multiply non-integer stuff because denom 1 and denom 2 are coming out of our get denominator 2 and get numerator as strings. Go ahead. Yeah, so we can just decide. We can decide, well, do I maybe want them to produce strings for me? Do I have a reason where I might need it as a string later on? Or am I always going to be working with this guy as a number? Probably always working with it as a number. So then we can say, let's do the conversion inside the function so we don't have to see it elsewhere. So for get numerator, we're going to say return the integer version of that guy. Right? If you were doing this in Java, you would have said integer.parse int answer. I would have given you the equivalent. Every single programming language has some facility for taking integers, making them strings, and taking strings and making them integers. Presumably, if it's filled with digits. All right, and we'll do the same thing for get denominator. I'll go ahead and do it for all of ours here, even though we're only using get denominator 2. All right, so now that error should go away because now multiplying our two denominators together, we're now doing it with numbers. Okay, I'm not returning anything yet. That's why we have the none. All right, so now we have actual numbers. So we have our common denom. And now we need to do our cross multiplication. So num1 is equal to num1 times denom 2. Num2 is equal to num2 times denom 1. I don't remember what we called it, but let's call it answer num is equal to num 1 plus num 2. All right, so then our final answer is going to be our answer num followed by a slash followed by our common denom, assuming we're not reducing at this point. So right now, common denom is a number, answer num is a number. I want to have a number followed by a slash followed by a number. I need to rebuild my string. How do I do that?
Did you build it?
Well, I mean, if I have right now a 1, let's just say I have a 1 and I have a 23, and I want to produce 1/23. I have these two things. I want to make something that looks like this. How do I build a string out of two numbers? Concatenation? So here we can say answer is equal to, now if I say new, or if I say answer num, concatenated with a slash, concatenated with common denom, this is going to give me an error. Before I even run this, what error is this going to give me? It's going to say I can't concatenate strings and integers. So it's going to tell me that this type is not defined. The plus sign doesn't work with ints and strings. All right, so how do I fix this? It only works with strings. Make our number strings. Now, can't I make this guy an int?
No.
Why not?
Number.
That doesn't make any sense to make that an int. If I walked up to you with a slash and I told you what's the numeric equivalent of this, the smartest answer you can give me as a computer scientist is the Unicode or ASCII value, right? Okay. But any normal person who's not going to be operating at that level, they're not going to be thinking about Unicode or ASCII, is just going to say, not a number. I don't know what you want from me, but you're on something. Especially if you're expecting a response. An old language, Visual Basic, that isn't really used anymore, used to give you answers when you asked it to convert stuff that didn't make any sense. I mean, you could have it add 2 ice cream cones together, and it would give you a number, a result, based on nothing. It was so stupid. It was really bad. All right. So we're not going to convert that guy to an int, but in order to make our concatenation function here, and this is an important piece, in Python, in order for us to make our concatenation work here, we do need to convert both of our numbers into strings. But many languages, in fact, all our compiled C-based languages do not require you to convert them to strings. As long as one of the two sides is a string, it will treat it as concatenation. Java's that way. So in Java, I could have written the first thing. I could have just said answer num concatenated with a slash, concatenated with common denom. It would recognize that, oh, that slash thing is a string. You must mean concatenation here. We'll take care of it. It doesn't make you convert them to strings. I don't have a super strong opinion of whether one makes more or less sense than the other. It's easy enough to fix, but just something for you to keep in your head as you're doing these things to make sure that it's all giving you the right outputs. I did check something here. Okay. For some reason, I thought I hadn't started the recording, but I did. All right. Okay, so now we have our answer from here. Now I need to finally return my answer. And there is those two numbers added together. So 123 over 23 plus 1 over 24 gives me 2975 over 552. Because we have a very large common denominator by multiplying those two guys together. Okay. Now, what if I want to reduce my fraction? This guy right here. So if I have 2975 and 552, and I want to reduce that, what does it mean to reduce a fraction? How do you go about if I'm trying to tell a computer that I want this guy reduced? If you're just doing this by hand, so let's give ourselves a smaller number here. Actually, let me. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So let's say I have something like 4/8. Okay. How do I reduce 4/8? Okay. How did you decide? So he said divide both the top and the bottom by 4, which then gets us to 1/2, right? How did you decide to divide both the top and the bottom by 4? Okay. How did you figure that out? So I have a numerator of a 4 and a denominator of 8. You wanted to find a common multiple of both of those to divide it. Why did you pick 4?
Yes, sir.
Okay, well, how are you going to explain that to a computer? We're starting to see the problem. Human beings are pretty good at solving problems. We just glance at that and say, oh, well, I mean, well, first of all, it can't be bigger than 4, right? It's the largest it can possibly be is the smaller of the two values. So we at least know that that's the starting point. All right, go ahead.
I was gonna say like use mod as a way to find if the number is divisible by 2. And I guess if it becomes a floating point number or it just starts adding a bunch of decimals is when you would probably stop. If that makes
Okay.
sense. Just more so the mod operator will tell us whether or not it's actually divisible.
Okay, so your gut feeling is that mod is involved here to determine whether something is evenly divisible by something. Yeah, because if it's evenly divisible by something, mod is going to give us a 0 when you try to divide it by that. Okay. So how do I figure out which is my, well, look here, let's just start writing a function. So reduce fraction will take in a fraction string, and our job is to reduce that fraction. All right, now in order to reduce the fraction, we first need to get our numerator and our denominator. We have to use our functions to extract those two pieces of information. So we'll call this num is get numerator of fraction string. Denom is equal to get denominator, call whichever one you want, of your fraction string. All right, so yeah, oh, thank you. Get denominator, blah. All right, so we built the tools, we might as well use them. Doesn't matter how complex they were, we already built it, tested them, we're happy, they seem to do what they should do. So now we could just rely on them for extracting numerators and denominators from fraction strings. Okay, so I have my numerator and my denominator. Now, how do I figure out what the largest possible divisor of these two values might be? Go ahead.
So you could use well, are you doing for loops yet or not?
It doesn't matter.
Okay, well, you can use a while loop and go through. First, you get the minimum value of the two, and then you.
All right, so let's start with that. And then I'll let you keep going after that. So first you said, let's find the minimum value of our numerator and denominator. Because the minimum value is the absolute biggest value that might evenly divide both of them, right? All right, so how do I get the minimum value of num and denom? Using only what we've taught in class so far.
So I would say just continuing with the mod operator, you start with, I guess whatever numerator denominator. You mod it by 2 and if
I don't want to do the math yet. I only want to ask the question, which value is smaller, numerator and denominator? So I want to create a variable called min, and I want this guy to hold the minimum value of numerator and denominator. Now, I will tell you that most programming languages have a function built into it for doing this, but we're not going to use it because it's an if statement. Go ahead.
Make a function with an if statement, like it takes two inputs A and B. If A is larger, turn that one. If not, return B. Or if A is smaller.
Okay, so here, let's just we'll say find max or find min. We want the smaller of two values. 1, num2. So if num1 is less than num2, return num1. Otherwise, return num2. Did I need an else here? Okay, why not? Yep. So if I'm still kicking, remember return makes the function immediately end. So if I'm still alive after this if statement, that means I didn't return in there, so I can just go ahead and return the other guy. But an else is not incorrect. So if you just like the feel of an if else that is more meaningful to you or reads better to you, this is perfectly fine. We're asking the question, if num1 is the smaller of num1 and num2, return num1. Otherwise, it must be num2, or they were equal, and then it didn't matter which one you returned. All right, so find min will give us the largest value that could possibly evenly divide both of these. So let's call this guy curval, and we'll call this we'll say find min of num and denom. All right. So after this line, curval will hold the biggest value that possibly can evenly divide both the numerator and the denominator. Okay. Now, do you know of any value that will definitely evenly divide the numerator and the denominator? Is there any number that is guaranteed to evenly divide numerator and denominator? 1. So we know we're going to find something, right? It might not help us because anything divided by 1 is going to leave it alone. So if it ultimately ends up being 1, that means the fraction was already reduced. Who cares? Computers are fast. We don't care if we're abusing its time. So we can have it check. All right, but curve value is the biggest possible value. So we'll say while curval is greater than 1. So if curval is greater than 1, we want to test to see if it evenly divides both the numerator and the denominator. All right, so keep going. You had your solution you were kicking with, or did I already break yours?
Oh, yeah.
I want to test. I want to ask, is the numerator evenly divisible by curval? And is the denominator evenly divisible by curval? I want both of those things to be true. Use an if statement, we're asking a question. So if numerator, now how do I ask, is numerator evenly divisible by curval? Mod 2? Mod curval. I don't want to know if it's even or odd. Modding by 2 will tell me if it's even or odd, right? If it's modding by 2 gives me a remainder of 0, it's an even number. Not all that important for this. In this case, I have a number, cur num. By my example I wrote here, cur num would be a 4, right? So if I'm operating off of this example, cur num is a 4. That's what we figured out is the minimum value between 4 and 8. So I want to find out, is 4 evenly divisible by 4? And is 8 evenly divisible by 4? How do I ask that question? Said mod. So num mod curval. If that guy's equal to what? How do I say is evenly divisible?
0.
Okay. So if when I take this number and I divide it by this number using integer division, modulus gives me the remainder of integer division. So if I take num and I divide it by curval and it gives me a remainder of 0, that means curval evenly divided num. Yep. So this only helps me in the first one, right? So this says, well, at the very least, num is evenly divisible by this guy. And denom, I think this is the right and for Python, but well, In Java, it's that guy. Is that what it is in Python? We'll find out pretty quick. It's going to scream in if this is not, but it's one of those two. I think it's actually the word and. So let me switch it back, but this is the same thing as we've mentioned a couple other times. Every language has a way of saying and. Most modern C-based languages use the double ampersand.
I'm so confused when
But I do want, let me finish writing this, but I do want to cover something that you've probably seen. And it will hopefully answer a question for some of you who have had some programming before, but didn't know what and why it gave me a certain answer. So we'll look at that here in a second. So, and denom mod curval is also equal to 0. So if curval evenly divides the numerator and the denominator, that means we currently have our final answer. We have the largest value that evenly divides both the numerator and the denominator. All right, so I want to now divide those. So we're going to say curval, I was dumbing down. Let's go this route. What do I want to say in response to saying if they're both evenly divisible? And do I, for reduced fraction, do I have my final answer here? I mean, I have everything I need to create my final answer. So I can say num is equal to num divided by curval. Denom is equal to denom divided by curval. The only way we possibly are inside this if statement is if those two evenly divide by curval. So now I want to return string version of num concatenated with a slash, concatenated with the string version of denom. Remember, return makes a function immediately end, so I don't have to worry about what other thing might happen. We also happen to know, I'm going to do this as an else because I think it is cleaner to see it visually. So if both num and denom are evenly divisible by curval, then I have my final answer because I am starting at the largest possible value and walking down towards 1. So that's why I'm returning the answer here. But if I'm still alive, if at least one of them did not get evenly divided by these, then what do I want to do? Subtract. Yeah. So curval is equal to curval minus 1. Curval started off as the biggest number that might evenly divide the numerator and the denominator because we went and found out what's the smallest value of these two. So once I had the smallest value of these two, I put it in a container called curval. And now I'm saying I want to whittle this guy down towards 1 because I know 1 will even divide everything. I'm going to whittle this guy down towards 1, and I want to find the biggest value here that will evenly divide both those guys because that is how I can divide or reduce these fractions. All right. So if I didn't find a number, the current curval evenly divides both of them, then we'll do one smaller curval, let it spin back up, and give me my answer. Now notice I'm continuing to go as long as curval is greater than 1, because I know that 1 will evenly divide it, right? So if I'm still alive after this while loop, I'm still kicking. What would I return here? Or what do we know about our fraction string? If I'm still alive here, it means it's already reduced, right? If I'm still alive right there, that means that I've survived this while loop and I've missed that return statement every single time because I didn't find any value that evenly divided both the numerator and the denominator. Now, I could have let it go down to 1 and let it naturally find it. And even though we know we're only going to be passing legal fractions into this, so we would never fail in our while loop, we potentially could have an answer of none if we didn't ever return a value, even though we knew that wasn't going to be a thing. So I'd say good programming practices, check all of the things that would require us to make a change to our fraction, returning the answer up here, which makes the function immediately end. Or if we're still alive here, I can just return fraction string. I don't need to do anything to it. It's already reduced. I don't have to rebuild it or anything like that. All right, that makes some sense. All right, so now we're going to say F3 is equal to reduced fraction of F3. And then we'll print F3 again. Oh, that guy was already reduced. Let's give ourselves a better, since we tested all this stuff already. We know 1/2 plus 1/4 will reduce. Okay, so there's our 6/8 and there's our 3/4. But now we did get 3.0 and 4.0 because we did floating point division. This guy, right here. What's the integer division? Double slash, like that. Or I could have said num is equal to the int version of num. Denom is equal to the int version of denom. Run that again, we get a better answer. If I take some number and I say, give me the integer version of this, it will truncate any decimal point places. We happen to know that the only way these things exist is if they are, it's going to be 0. We might as well have done integer division. Didn't matter which direction we went. So probably the correct way here is to do the integer division so we don't have to doctor those up afterwards, and we'll still get our correct answer. All right, questions about any of that? Good. Using our example of like 4/8 like I had here. Let's go this route so we can see it. So when we ask which of these two values is smaller, we come up with 4. 4 is the biggest value that will evenly divide both of these guys. So then I go through, so kernum starts off at 4. I ask myself, is 4 when divided by 4 equal to 0? Is that a true statement? It is. But is 9 when divided by 4 equal to 0? That's false. It did not, they both didn't evenly divide it. So this guy is false. This guy is true. True and false is false. So now I need to go and try another version of kernum. So kernum is equal to, or what I call it kerval, but whatever. Kernum is equal to whatever it currently is minus 1. So 4 didn't work, let's try 3. 3 didn't work, let's try 2. 2 didn't work, let's try 1. 1's gonna work. one's gonna work. All right. So now, that makes sense? All right, so now let me try to trick some of you who maybe have done some of these things before. Let me first force the right answer here. So I'm going to say print. Actually, let me just test something here real quick, just to see if it supports both the. Yeah, doesn't like that. All right, so then in my example here, let me just see if I want to get it to produce something before I teach it. Otherwise, I'll just look at it in Java here. So if I say 5 and 7. Okay, good. All right. So when I say 26 and 13, now somebody mentioned in most C-based programming languages, the and/or operators. Most modern languages use this guy for and that guy for or. Python happens to use the word and or. But if I take a number like 26, if I do 26 and 13 like that, which we just saw does work in Python, I get an answer. What answer are we expecting to get there? Well, what is one and sign instead of two? Those of you who've had C, C++, Java, C#, you're used to using this version of an and instead of the word and, or this version of an or instead of the word or. But I've accidentally only used one of those guys. But I got an answer. Do you know what that answer represents? What operator is this in our modern programming languages? Nope. It's a mathematical operator, not a Boolean expression. This guy is the bitwise and operator. This guy is the bitwise or operator. This guy is the bitwise XOR operator, exclusive OR operator. And we'll talk more about that next time, but this is actually dealing with those two numbers in binary and doing an and on each individual bit of them to come up with a final answer, which is also in binary, which gives us a number. All right. So next week, remember, come in person. Tuesday and Thursday, we're going to have like a mini hackathon in here where you'll be solving a whole bunch of problems that aren't any more difficult than what we did in class today. I will put a link into the slides, our final version of what we have right now. So you have this as examples. And I will see everybody. Yep, have a good one.